This is Algebra 2, Chapter 5, Unit 4, Part 1. The greatest common factor. GCF stands for the greatest common factor. So, we have in our first example 12a cubed plus 10a squared. We want to find the greatest common factor of both of those terms. Okay, so we're looking for what these terms have in common. In this case, both 12 and 10 are divisible by 2, and that is the greatest common factor. Next, we look at the variable. So we have an a cubed here and an a squared here. So a goes into both of those. So we're looking for the minimum number that a goes into both of them, which is a squared. So we're going to factor out a 2a squared. Once we do that, we take 12a cubed divided by 2a squared, which gives us 6a. And then we have 10a squared divided by 2a squared, so 10 divided by 2 is 5, and a squared cancel out, so it's just 5. Number 2, we have 14m to the 8th power, n to the 5th power, minus 7m squared, n squared. So the first thing we look for is we look at the integers, okay, the 14 and negative 7. We were looking for the greatest common factor of both 14 and 7. In this case, it is 7. So we're going to go ahead and factor out a 7. Next, we're going to look at the variables, or the letters. So we have m to the 8th and m squared. Well, m is in both terms, so we know we can factor out an m. So we're going to go ahead and factor out an m squared because that's the minimum m that we have. We can't factor out anything greater than m squared because then it would end up negative. Next, we're going to look at the n to the 5th and n squared. We have our n is in both terms, so we know we can factor out an n, and our minimum is this n squared over here. So we factor out 7m squared and n squared. Take 14 divided by 7 equals 2. M to the 8th divided by m squared, well, 8 minus 2 is 6. N to the 5th divided by n squared, well, we're left with n to the 3rd. And we have 7m squared n squared divided by 7m squared n squared, and that equals negative 1. Now we're going to look at difference of squares. So perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and the list goes on. The rule of difference of perfect squares is a squared minus b squared equals parentheses a plus b times parentheses a minus b. Notice that the numbers within the parentheses, or the variables in this case, is the same except for that plus and minus sign. That plus and minus sign is just going to cancel out your middle term or your x term or your b value when you look at standard notation. So let's look at some examples. Our first example is number 3, we have 9x squared minus 49y squared. What do we notice about 9 and 49? They're both perfect squares. Okay, so 3 squared equals 9, and 7 squared equals 49. Also, x times x equals x squared, and y times y equals y squared, so those are both perfect squares as well. So we want to go ahead and take the difference or factor it out, and we notice that we're going to put our 3 right here, our 3x right here, and it's going to be the same in both places because we want to get that middle term, that x term or that b term, to cancel out. Next, we have our 7, and we plug in 7y in both places because that is the square root of 49 and y squared. And then we want to make sure we set our signs opposite of each other so it cancels out that middle value. Next, number 6, we have 10w to the 5th power minus 10w. Well, we're going to look for our greatest common factor here. And in this case, our greatest common factor is 10. And our variables, we have variables in both. So it is w. Okay, so we factor out a 10w, and we take 10w to the fifth divided by 10w equals w to the fourth, and negative 10w divided by 10w equals negative 1. Then, but we're not done. We still have this w to the fourth minus 1. Well, we can take the square root of both of those. Okay, so we still have our 10w. When we take the square root of w to the fourth minus 1, we get w squared and w squared. So w to the second and w to the second power. And then we don't have that middle term, remember, that b value. So our 1, the square root of 1, is going to be 1. And we're going to set them to opposite signs, so a negative 1 and a positive 1, because we're getting rid of that middle term, that b or that x term. Next, we can, this is w squared plus 1 is prime, because no matter what, if you have a negative 1 and a negative 1, that's going to equal negative 2. And if you have a positive 1 and a positive 1, that's going to equal positive 2. So that is a prime, that w squared plus 1 is prime. We can look at w squared minus 1 because we know that we need a positive and a negative to equal that negative sign. So we need a positive 1 and a negative 1. So our answer is going to be 10w times w squared plus 1 times w plus 1 times w minus 1. Now, I would like you to try numbers 4 through 5 on your own. Go ahead and pause the video while you try numbers 4 through 5. Here are the answers to number 4 through 5. Next, we're looking at sum of cubes. Perfect cubes are at x to the third power. So we have 1, 8, 27, 64, 125, 216, 343, 512, and the list goes on. The rule for sum of cubes is a cubed plus b cubed equals parentheses a plus b times parentheses a squared minus ab plus b squared. So it's important to remember that when you're working with these sums of cubes. So let's look at some examples. We have number 7, we have x cubed plus 27. So we're looking for our cube. We know that x times x times x equals x cubed. And we know that 3 times 3 times 3 equals 27, or 3 to the third power would equal 27. So when we break it down, we're going to put x plus 3 right here, okay? Because we go back, our a value would be the x, and our b value would be the 3. And so x plus 3. Now we go to our trinomial. So we have x squared, or our a value squared, minus our b value, okay, because this is in that rule, our rule, 3b times our x times our a value, which is 3x, plus our b value squared. So 3 times 3 equals 9. Next, number 10, we have 24c to the 4th d plus 375c times d to the 4th. I know that I can factor out of this a 3. I also look at the variables, and there's a c in both, so I know I can factor out 1c. I also look at the d value, and there is a d in both, so I can factor out 1d. So I have 3cd factored out. So 24 divided by 3 equals 8. C to the 4th divided by c, well, 4 minus 1 equals 3. And d cancel each other out. Next, I have 375 divided by 3 equals 125. And then c divided by c equals, well, that cancels out. And d to the 4th divided by d, well, we're left with 3d. So d to the third power. I notice when looking at my 8, that is a perfect cube. Same with 125. That is a perfect cube as well. So I know that I'm not done. I now look at my perfect cube. So I forget about this 3cd for a while. And so what number multiplied by raised to the third exponent equals 8? Well, that is 2. 2 times 2 is 4 times 2 equals 8. And then c to the third exponent is going to be c to the third. Next, I look at the 125. I'm looking for what number or integer that when cubed equals 125. In this case, 5 times 5 is 25. 25 times 5 equals 125. So my answer is going to be 5d cubed. Next, I'm going to go ahead and plug that in according to our rule, where we have that a plus b times a squared minus ab plus b squared. So I go ahead and bring back in that 3cd, put that in front. Now I bring in my a plus my b. So I have a is 2c, and my b is 5d, so a plus b. Next, I have my x value squared. So my x value is 2c, or my a value squared, which is 2c, so 4, and c squared, so 4c squared. And then I have my 2 times 5, which is negative. Then I have my negative a times my b value, which is negative 2 times 5, which is 10, c, and d, which is negative 10cd, and plus my b value, which is 5d squared, so 5 times 5 is 25, and d times d is d squared. Now, go ahead and pause the video while you kind of take notes, look over everything, and then please do numbers 8 through 9 on your own. Here. Okay. Difference of cubes. We have rule is a to the third minus b to the third equals a minus b times a squared plus ab plus b squared. Well, it's a lot like what we did with sum of cubes, except we're dealing with subtraction. We have x cubed minus 1, so we know that x cubed is a perfect cube. So we have x raised to the third power, and then 1 is also a perfect cube. So we have 1 to the third power as well. Now we go ahead and we set it up. We have our a minus our b value. So our a value is x. Our b value is 1. So we have x minus 1. And then a squared, so x squared, plus a times b, which is x times 1, which would just be x. And then 1 squared, which is 1. Number 14, we have 2x cubed minus 54y cubed. So I know that I can factor out first a 2 from both of these. So I go ahead and factor out a 2, and I'm left with x cubed minus 27y cubed. I want to get down to this perfect cube. Well, x cubed is x to the third power minus, and then 27, well, 3 times 3 times 3 equals 27, so it'll be 3y cubed. Next, I bring back down that 2, and I take my a minus my b value, so x is my a value, my b value is 3y, so a minus 3y, and then I have x squared plus 3xy plus 9y squared. So a is x, so x squared, and then 3, so then my a times my b value, which is 3 times my 3y, and then my x. X always goes before y. Now I have my b value squared, so 3y squared equals 9 times y squared. Now try numbers 12 through 13 on your own. Here are trinomials. So we have n fourth plus 2n squared minus 24, n squared plus 6, and n squared minus 4. You're looking for factors of 24 that when added together equals 2. Okay, then you could go ahead and break down even further that n squared minus 4. So we can break that down into n plus 2 and n minus 2. We can't break down the n squared plus 6, that is prime. Now try numbers 16 through 20 on your own. Go ahead and do that, and pause the video while you try those. Okay? Now, here are the answers for 16 through 20. Go ahead and next we will be talking about full terms, so go ahead and watch part 2.